We're here today to talk about NX One-Step Formability. It's a really powerful, a really cool tool. Just very briefly, my name is Dan Turk, and I'm an application engineer with Geometric Solutions. For our agenda today, it's really going to be a simple agenda. The question is, can you flatten that? It's kind of cool when you think about the different sheet metal parts that we're able to create. Some, they're made on a press brake and there are just a couple of flanges. Can you flatten them? No problem. But then you get some sheet metal pieces like this. Look at this monster. Are we able to flatten that? Well, with one-step formability, we're going to see that we can flatten it. Now, briefly about the company that I work for. So I work for Geometric Solutions. We sell Siemens software solutions, but we're part of the larger Waltonen family of companies. So it's neat if you think about it. Geo, we sell the software. Waltonen Engineering, there we've got hundreds of seats of the software and hundreds of engineers, but they're using it every day to design things. And then take that to the end, well, we have Independence Tooling Solutions. They're taking the things that are designed with the software that we sell, and they're actually creating it. So you could say we have an end-to-end solution. The owner of our company, Lloyd Brown, he put it best. Our ability to successfully partner with our customers comes from our experience in using the tools we sell every day. So it's not just that we are selling these tools, no, we're using them. So let's get started talking about NX One-Step Formability. The first question would be, why? Why do we need a tool like this? Well, oftentimes we'll take a sheet metal part, we'll bring it into NX, and then we'll try to flatten it. We'll try to create a flat pattern just using the sheet metal tools. So with this part that you can see on my screen, we converted it into a sheet metal part and tried to flatten it. Now, the NX sheet metal flattener, it's pretty good. You can see it was able to flatten some of this. So it was able to flatten these bends. But when it came to the perimeter, it just couldn't do it. So the question is, what do you do when your standard flat pattern, when it just gives up, when it throws its hands in the air? That's where this tool, one-step formability, comes into play. Because with one-step formability, can you flatten it? Yes, you can. Let's jump into NX and actually take a look at this tool in action. So what you're seeing on my screen, this is actually the front end of a car. Lots and lots of sheet metal. It's actually the body in white. So tons of sheet metal parts. Boy, I don't think there is a single part in here that is just done on a press brake. Let's take and try to flatten a couple of these pieces, and let's see if it works. We're going to start with this first piece, the one that I just showed on the screen, because it's a bit easier. Then we'll get progressively harder, and then we're going to finish up with this monster. And I'm just highlighting this in the context so you can see just how big that is. It's like the whole car, right? Well, let's see how this tool works. So here's our first part. Now this one, it's admittedly easy, but just remember the standard sheet metal tool could not flatten it. So I'm going to use one-step formability. And what I'm going to do is I'm just going to choose the faces, so just the outside faces of this part. And of course I've got, tangent faces turned on just to make it a little bit quicker. And then I just kind of step on through the different options that I have. I'm going to go to this boundary conditions. And what the boundary conditions do, or the way I like to think of it, is it's kind of like how you would hold the part or how you would clamp it. So I'm just going to choose this little area down here. Next up, material. And for all of these, we're going to stick with steel. But I just have this open so you can see that there are a ton of different materials that you can flatten. And if the material that you need is not listed, no problem, you can actually just create it. Lastly, I'm going to specify the vector. So this is for the draw direction. I'll just pick this face. You'll notice under surface types, I can choose, do I want the outer, inner, middle? And since I selected outer, I'm just going to stick with that. And then I'm going to come to my calculation. Now this little tab right here, this little grouping, this is everything when it comes to one-step formability. Because what we're actually going to do is create a mesh. So we commonly hear FEA, finite element analysis. Well, what we're doing is FEM, finite element modeling. So I'm just creating this mesh. And you can start to see all the triangles. And then the last thing I'm going to do is I'm going to click this calculation. Now what this calculation is going to do is it's actually taking and it's figuring out what this part is going to look like flat, as you can see here. So one-step formability, we're able to take this somewhat complex part, I mean not really that complex, but we're able to take and flatten it. That way, if we're going to stamp this part and we want to get the blank size, we've got it. With this tool though, you can do more than just flatten something. Underneath result display, I could say, let me see what the thickness of this part is going to be. So if this was flattened, or excuse me, if we took the flat blank and then we stamped it, where is it going to be a little bit thinner? What's the thickness? You can see the hot spots. Or if we take a look at the stress on this part, how about the strain? Looks pretty good. It gives us a couple of other options in here as well. We can display just the flattened shape, or we can create a profile. We could say we want to take that flattened shape and we want to turn it into a sheet. And then we've got this last option, which is report. So I'm going to click that. And what this report tool does is it's actually going to take all of those measurements and put it in a really nice document. So I'm just going to hide the curves just so my report looks better. So I'll just choose a nice camera view, hit OK. Now I'm at the next, the first test here, the thickness. And you could take and move these around if you wanted to highlight different areas. Okay. And we're basically just kind of stepping through our parts. And what that report actually looks like, let me pull that up. It actually gives us this nice little XML file. So you can go through, you can look at the material, look at some of the mathematical properties. You can have the reports. What is it going to look like? What's the thinning, the stress, the strain? What's the flattened shape? What is all that going to be? And you noticed it was just with a couple of button clicks, we were able to get that. So pretty cool. But let's take this a step further. Let's just say though, that we have our blank and for some reason, we want it to be a little bit larger. Maybe we want to just bump the size of it a bit. Well, that's easy to do. I'm just going to create a sketch just on this face back here. And I'll just project that entire flat pattern, or that blank rather, right onto my part. Then I'll just click to do an offset. And look at that. That easily, we're able to take that blank shape, in this case, offset it. But you could go in and make any other adjustments, any other changes that you would want. So a really nice tool. So part number one, the question was, can we flatten it? And the answer, yes, we can. Let's take a look at the next piece. So for this one, we're going to use some of the other NX tools that we have. Maybe I want to take and I want to flatten this piece, but let's just say I don't actually want these holes in there. Maybe they're clearance holes. So I'm just going to use the synchronous technology. So I'll just delete those faces out of there, no problem. And maybe I look at this and I say, at the front, I want this to be just a little bit longer. So maybe we're going to put a clamp or something at that end. So let's make that a little bit longer. What's nice is you're using NX here, so you can do everything really easily. I'm going to click One-Step Formability. And again, I'm going to just choose what do I want to flatten. So I've just picked those outside faces. I'll come down to my boundary conditions. And I'll just pick these curves here at the end. We'll keep on going through. Material, steel, yep, that's good. Draw direction. I'll just pick that face. Then when it comes to thickness, we actually have a question, do you have to have infer thickness on? No, you don't. If we took a measurement, then you could key in anything you want for that thickness. The nice thing about this would be if you were just given surface bodies and you know what the thickness is, well, then you can just key it in manually. So we'll keep infer on, infer element size, and then I'll do my mesh. So it meshed it pretty quickly. We'll go ahead and run our calculation. Now this part is a bit more complex, so it is going to take a little bit more time to run that calculation. But that was pretty quick actually. What's cool, I can go back in, display the stress, the thickness, all these different pieces. But I just want to highlight something real quick. Notice on the left side, underneath the thickness, the left side, we've got a real hot spot. On the right side, not as much. What's neat about this tool is if I were to go back in and change my vector, change that draw direction, so you can see how it's angled now. Rerun the mesh. Rerun the calculation. And again, this is going to take a few seconds. It surprises me every time when how fast it is. And then I want to look at the thickness and notice how it changed. So we still have the hot spot on the left, but you remember the one on the right, it was barely there? Not anymore. So that's really showing us how the analysis portion of this tool works. And remember, because we're using NX, it was really easy to delete a face, move a face, and so on. So part number 2, can you flatten that? Yes, you can. All right, we're going to move to our next part. And this is the monster. Just to give some clarity, let me go back to the actual car. This is how big this piece is. So let's see if we can take and flatten this guy. So one-step formability. I'm going to choose my tangent faces. The question was asked, could you use body faces? well, yeah, you've got all the faces that you could want. So tangent faces, just make my picks. Now, before I move down, I just want you to notice something. Select faces, 1,029 faces. This guy is a monster. So let's see if we're able to get it to work. I'm going to select my boundary condition. And again, the way to think of this is just how you'd be holding the part. Because this piece is so big, everything is going to be like a half a step slow. So I'm going to pick one side, and then I'll just choose one more side for my boundary. And like I said, because it's such a big part, everything's running just a little bit slow, including my pre-selection. All right, now that that's set, material, steel, that's good. Vector for our draw direction. When it comes to the draw direction for the vector, this is something that you have to just decide, based on your company standards and on the tool that you're using. The question was asked, does it matter if you use the exterior or the interior? No, it doesn't. And you can see there's outer underneath this thickness, outer, outer, middle, and inner. I'm going to go ahead and mesh this guy. And here, everything is going to take a little bit longer. So hopefully not too long, because we're doing this as a live webinar. But the idea here is that we're able to take a gigantic part, very complex, and we're going to see if we can flatten it, if we can create that blank. So our mesh is running. That was pretty, looks like it's going pretty quickly. All right, we've got the mesh. Let's run the calculation. And excuse me, and this will take just a little bit of time, but not as long as it would take for you to just try to create the blanks yourself. Okay, that was really fast. It's already done, that's cool. But look at that. There's our flat. Can you flatten this big monster of a part? Yes, you can. We can go in and look at the results, and it's showing us the hot spots. And it makes sense, doesn't it, that it would be in these corners where the material is, so to speak, smashed. We can look at the stress, strain, and so on. Another question was asked, do you need to use constraints at all? That is a good question. The reason I like to use them is it takes my flat pattern, or it takes my blank, and when I use the constraints, it kind of keeps it in line with the part. If you don't use it, sometimes the flat or the blank will just like run right through the middle of the part. So it's kind of just having it set up like that. A couple of other questions that we have. How accurate is the flat blank? Well, we believe it's very accurate. We're using finite element modeling, so we could say it's probably more accurate than just the typical flat pattern that we have. Another question was, can you add a hole or opening in the flat and reform it? And actually the answer to that is no, because what this is really giving us is just a bunch of splines. So in the first part that we did, I took these curves and I brought them into a sketch, really that's all that you've got. So it's not a matter of reforming a bunch of curves, but rather doing the opposite, just taking the solid model and flattening it. So that is one of the limitations. Let's go back to our little presentation that we have. Actually, I've got another question. Oh, this is an answer to that previous question from Ken. You can use flattening and reforming in surfacing to reproject curves. So you can use these guys in conjunction. So when we think about NX One-Step Formability, the main thing I wanted to highlight is, did you notice just how easy it was to use? It was very fast. And it's not just taking your part and making a blank, but you're actually getting to run some analysis. Is the part you're going to make, is it actually going to work? Because you could take something and flatten it, but maybe you can't actually form it in real life. Well, that's where we're able to test the thickness, the strain, and so on. I did have one more question. Is the flat associative if formed part changes, or do you have to rerun? And actually, we can go back to our NX. Let me just hit OK. And you can see it's just giving us these curves. So we're going to have to actually take and rerun it. But even for this monster of a part, it only took us just a few minutes. But good question. So the whole point of our agenda today was the question. Just one simple question. Can you flatten that? Well, with one-step formability, the answer is always yes, you can. You can flatten anything. In fact, the first time I was exposed to this, our customer wanted to see if they could flatten glass. Can you imagine that? Flattening glass. So if you can flatten glass, you can flatten anything. Again, this is NX One-Step Formability. I want to thank everybody for your time and your attention. You can see we've got a little QR code on the screen. Go ahead and scan that, and that'll tell you about more of our upcoming webinars that we're going to have. We also have an email address, sales@goplm.com. And I'd like to thank you all for all of your questions. We had a lot of questions today, and that really helps everybody. So thanks so much. Have a great day and be safe.